Good evening, all. So in the morning class, I have discussed a little bit about the network slicing, and I think I covered most of the content really. So in there, actually, we discussed about the main concept of network slicing. So the main concept with network slicing is the creation of virtual networks on a certain infrastructure, such that the different virtual networks can cater different requirements. So these virtual networks are known as slices. So network slices means those virtual networks. And these network slices are like independent and virtual slices. And these are actually used on the same physical infrastructure. So the network slicing deployment is something that is currently ongoing work. So like I think customers I think will be getting some more. I think the customers will have to we'll have to wait a little bit to see the real implementation of the network slices. However, like some companies such as Nokia, Ericsson, other mobile vendors like Vodafone, they are currently working with the network slicing concepts in their operating systems. So so this is like a very new technology, I would say, and it is kind of still progressing. So this network slicing like concept is useful in situations where we have different customer requirements. So there are slices which are dedicated for enhanced mobile broadband, then ultra reliable low latency communications and massive machine type communications, and so on. Depending on the application, the slice can be defined. So these different slices that we define are known as these network slices. These are virtual slices, and therefore these are slices which are defined using softwares. So, so these software-based virtual networks are deployed on the same physical infrastructure. So, although this concept is presented in a kind of a simple manner, actual implementation of this network slicing concept is really complex, because you need to think about different combinations of networks applied on the same physical infrastructure. So if you cannot get this correct, combination of the slices, then sometimes you might not be able to provide the customer needs as expected. So when we discuss about the network slicing, mainly we can categorize the slices under 3 slices. I mean, basically you can have any number of slices, but for our, I mean, for the standard scenario, we are considering that we are dedicating slices for these 3 applications of the 5G network. So network slicing concept comes basically with the 5G telecommunication standards, and there are 4 5G requirements, which are basically this enhanced mobile broadband, URLLC, and MMTC have been considered when forming these network slices. So 3 slices are defined basically for each of these requirements or each of these services. So when we move beyond that, when we go towards 6G, the requirements or the required performance from the 6G telecommunications is higher than 5G. So different use cases of um, of the telecommunication network is considered for 6G um, telecommunications. So in 6G, we do have this EMBB and these MMTC and URLLC service requirements, but those requirements have been subdivided into user-specific cases, such as autonomous driving, augmented reality, uh, so on and so on. Sometimes like um, AI-enabled robot communications. So those kind of applications have risen up. So because of those things, the user-specific requirements have to be provided to the user, which means that if the user requires that they need certain data rates and they need certain, uh, they need some performances uh, in terms of latency, in terms of bit rate, then the mobile operator has to provide such services as the customer is expecting. So when we are deploying such kind of network slices, therefore, we need to use many technologies, which includes software-defined networking, network function virtualization, edge computing, network orchestration, network function chaining, network slicing, management and control, security and privacy. So these are some of the main technologies that can be used. When we discuss about the benefits of using network slicing, uh, the one of the main, advantages could be considered as the customization of the services that we provide for different users. What I mean by that is that if we provide services, when we provide services to the users, we can provide them customer specific services. So depending on the customer requirement, we are providing the service. So that flexibility can be found with the network slicing. And especially with the IoT applications, network slicing is beneficial because of this reason. The IoT devices can be of different types. IoT devices can comprise of augmented reality applications and also online gaming applications, which require high data rates. So for those kind of users, we have to provide EMBB services or enhanced mobile broadband services, where you allocate a large bandwidth for the user such that the data rate per second is very high. It could be in the gigahertz, terahertz region, gigabits, terabits range. So per second, you are getting gigabits of data and terabits of data, that range. So you can basically, based on the specific device that you are using, you can ask for certain specific performance from the mobile operators. So for IoT applications, we consider an IoT network that has different types of devices. That includes devices that require higher data rates and other devices which require low latency communications and other devices that requires like massive connectivity. Then such kind of applications have to be addressed separately. So different network slices can be created in the virtual networks to provide each of those customer requirements. So one of the companies that are doing that is Nokia. So you saw a video regarding Nokia and its network slicing concept. So the Nokia has separate way of creating slices and providing the users the network slicing resources. So they have the certain specific way of forming a network slice, and also they have used the software defined networking technology to control the network slice. So anyway, the network slicing concept is useful for the IoT applications because there are different types of users using the IoT network, and those different users require different services. So once that is there, different slices can be allocated for the different types of users. And also we can optimize the network's resources rather than using the same network components for a certain service. We can try to optimize the network components such that those can be optimized to provide services to multiple users at the same time. And also with the network slicing, we isolate the communication uh, for each service that is required, that is requested by the customer. So what I mean by is that each slice is isolated from another slice. So the operation that is done in one slice is isolated from another slice. So it is said that it can provide security to the communication. So each slice will be isolated from another slice. So therefore the communication will be within that slice, and therefore the data will be secure in that standpoint. So apart from that, quality of service guarantees will be satisfied, which means that the quality of service required by the customer will be guaranteed by using the network slices, and also by considering the service level agreement that the mobile operator has agreed to provide before providing the slice connectivity to the user. So if a certain specific user requires some kind of service, the mobile operator has an agreement called service level agreement, or we call that SLA, and that SLA agreement specifies up to what extent the performance will be provided by the mobile operator. So that quality of service will be determined before connecting those devices into the network, and the mobile operator will provide the service up to that level. The scalability and the device density. So what I mean by scalability is that if you have a scalable network, that means that you can add more and more devices into the network. And even though you add those many devices, the network performance will not deteriorate. What I mean by is that even though like you add a lot of massive number of maybe devices to this IoT network, the IoT network performance will not degrade. So that happens because of this network slice concept, which is used to separate out the customer requirements and build separate slices for different customer requirements. So by doing so, each customer requirements can be handled separately. So even though multiple devices or large number of devices are added to this same, network, that network can handle all the requirements of each of the customer because of its ability to flexibly, address those uh, concerns. So I think in the morning session, I discussed with the students regarding the functioning of the network slicing in Nokia, and how they are using Nokia, how they are using the network slicing concept in their networks. So up to this point, any questions? Okay, with regard to the Nokia SDN controller, the SDN technology is used in the Nokia transport network, which is between the radio access network and the core network. So we will get into that point. So basically, they are using SDN technology and the NFV technology to enable the operations of the components in the transport network. Network components. Okay, so when you consider a certain example in here, the example will be a situation where there is a public safety application provider who creates an application that that provides public safety services. So the customer will be having a certain application which is related to public safety, and the customer will be able to use any of these services given in here, which are basically critical voice data, drone traffic control, drone video feeds, first responder vital sign, and location services. So these are the services provided by the application that I mentioned about public safety. So this application is available at the customer. So the customer has maybe a mobile phone which has this application. So each of these services separately considered has a certain communication requirement. So what I mean by that is that if the service that the customer requires for critical voice services, then the network should transmit that data with low latency, and they can use low bandwidth. The reason for low bandwidth is that the critical voice might contain short data or short length data. So rather than like large data or like lengthy data, this will have a short short packet transmissions. So therefore, the low bandwidth is sufficient for the communication. So likewise, different services will be requiring different communication requirements. So likewise, we can see that each of the services will ask for different requirements from the communication networks. So once those service requirements are given to the mobile operator, the public safety application provider gives those data to the mobile operator, which we can also call as communication service provider. So the communication service provider will give something called the service level agreement, or SLA, to the customer. Customer in here means the public safety application provider. So they will obtain the service level agreement. The service level agreement will specify the kind of the provided service details regarding the provided service in terms of data rate values, latency and beta rates, and so on. So the service level agreement mentions like what is the performance that will be offered to the customer under each requested service. So for this specific public safety application, this service level agreement will provide different services for each of the services, and those will be specified in this agreement. So after you have created the SLA agreement, now the next thing that will happen is that this network slicing orchestrator, there will be um, a component that will orchestrate the network slice. So the network slice orchestrator means a component that manages the network slice. So orchestrator means manage like multiple networks. So not only one, but it will manage multiple networks. So orchestrator is actually controlling multiple controllers. So you know that in SDN controller, we learned about the controller, SDN controller, controlling multiple network components. So in contrast, network orchestrator is a component that controls not only one controller, but multiple controllers. So in here, the network slice will be consisting of 3 controllers. One controller is the radio access network slice controller, and then transport slice controller and 5G core slice controller. So these controllers are defined for each of these controllers are defined for their own corresponding network. So radio access network will be controlled by the RAN slice controller. Then transport network will be controlled by the transport slice controller. Then 5G core slice controller will be controlled by the controller will control the core network. So these three networks will be controlled by these slice controllers. So that is how Nokia has defined their slice. So they have defined it in this manner such that they control different network components separately. However, they are all combined together to form the slice from the customer to the application location where the applications are stored. So the application could be stored in a data center in the cloud. So based on the location of the processing, the slice will be formed, and the slice will be formed from the customer to the data center. So as I said before, the network slice orchestrator is performing as a controller of these RAN slice controller, transport slice controller, and 5G core slice controller. So this creates the end-to-end slice from the source to the destination, from the customer to the destination. So the transport slice, when we take specifically, will be considered the place where the SDN controller is managing the data traffic of each of the slices separately. So once you receive the data from the RAN network, the data will be routed through this backhaul links between the RAN or the radio access network and the core network. So once the data receives there, the data in the intermediate network, which is the transport network, will be controlled by the SDN controller. So the RAN, actually radio access network, is basically doing the collection of data part, and the data will be added to this transport network. There are like massive number of network components which are belonging to the same mobile operator, and the SDN controller has to obtain the optimal route to forward the data through this massive number of network components in this transport network. So although there are only a couple of routers, switches, and other network components shown in here, which are shown by R1, R2, R3, likewise, there are multiple of them in the same domain, in the same transport network. So once you are receiving some data from the random access network or the radio access network, then you need to find the optimal path to forward the data from one location of the transport network to the end point of the transport network. So that part, optimal routing part, will be done by this SDN controller or the software defined networking controller. So we learned about the software defined networking architecture and its technology. So I believe that technology you can understand. So in here, same thing is happening of what we discussed. So basically, the SDN controller will be having connections with each of these network components that are there in the transport network. Each of these devices will provide some feedback to the controller regarding their status. So they will inform the SDN controller regarding the data traffic that they observe, and if they have some kind of inactiveness, that also will be notified to the SDN controller. Apart from that, SDN controller will observe the packet delays that happen through the network once the packet is transferring or transmitting through the network towards the core network. So SDN controller will observe the data metrics, performance of the network in terms of metrics such as the packet losses, packet delay, and also jitter, or the kind of loss in communication and any kind of sudden disturbances to the communication link. So SDN controller will observe those metrics, and based on those metrics, SDN controller will make decisions on the optimal path to forward the data from one location to the other location in the transport network. So if by any chance there's some kind of a broken link in the network slice in this transport network. Then the SDN controller will update the initial routing to a new routing that will prevent the delay that occurs when we are transmitting data through a broken link. So the optimal route will be updated from time to time, and those updates will be happening because of the SDN controller observing the inactive links in the network and inactive components in the network. So if there are any problems in certain route, such route will be identified by the SDN controller. The SDN controller will provide an update route to the network components uh, to avoid any kind of delays or any kind of performance degradations. So network slicing, so therefore works with those SDN technologies. And apart from that, there could be several slices working in simultaneously in the same on the same physical infrastructure. So when we consider about this scenario where this is shown, so in this case, there's one slice called public safety slice, which is a safety slice or which is used to provide public safety services, and another slice called gaming slice, which is used to provide services to gaming users. So people who want to play games, online games, for example, can use this slice. So based on the different slice, the amount of quality of service that is provided to the user might differ. So public safety services will be separately handled by one single slice. Gaming slice will be separately handled by another slice. So when these slices are functioning, they will be kind of independent and isolated from one another. So there's no impact from one slice to another slice, basically. So as I said before, if there's some kind of a link failure, the SDN controller will observe it and will take action to reroute the path from a certain sort of source to the destination, and will send the data in the updated route until the broken links and broken components are replaced and maintained. So up to this point, we have learned about what network slicing is, basically the concept behind network slicing, and then about how we can deploy network slicing. We have discussed about Nokia, how Nokia implements network slicing, and then we discussed about the properties of the network slices. So still some challenges can be available in network slicing concept. So one of the challenges could be how we can share the resources between the different virtual networks. So depending on the same physical infrastructure, we have to depend on the same physical infrastructure to provide the different services of the network slices. However, like when we are using the same infrastructure, sometimes the resource allocation for each slice have to be properly organized. Otherwise, some slice will get more resources, another slice will get less resources. So resource sharing can be a problem with the network slicing, and it needs to be organized properly such that each customer is, fairly treated. Dynamic slice creation and management is another challenge. So where the dynamic slice creation is happening using the virtual networks. The virtual networks are run through software programs. So we need to have a software program that can create these virtual networks and also create those networks without impacting other slices. So such kind of dynamic slice creation and management will still be an issue or a challenge with the network slicing. So dynamically changing the slice or updating the slice, creating a slice can be a challenge. So for under dynamic applications or in situations where the the customers are requesting different services dynamically, then creation of network slices based on those requirements can be a challenge at times. Another challenge will be basically the isolation among network slices, which we can consider as the problem that occurs when we have multiple slices. So if we have public safety slice and if we have a gaming slice, although the concept is that one slice does not like affect the other slice, sometimes actually implementing them, that can be a problem because we are implementing all these slices in the same network infrastructure. Sometimes the working of one slice might affect the working of another slice. So maintaining the isolation between slices also could pose a certain issue or a challenge in the network slicing. Security in the network slicing. So security in the network slicing means security of data in each of the network slicing could be a challenge. So the reason being that although we try to maintain the isolation between slices, sometimes if the slices overlap or they simultaneously, work together, sometimes there could be some data that is, accessible by other slices. So if one slice's data can be accessed by another slice, then the security is lost. Security of the data is lost. So we have to make sure that the data stays within one slice and does not go to another slice or does not get mixed with the communication of another slice. So security of the network slicing is another challenge that is still currently, like a significant challenge with the network slicing. So network slicing has currently been implemented in the real world as well. So companies such as Ericsson has used network slicing for disaster management, and they have already used network slicing concept for that. Another application where you need network slicing would be, football stadiums and, watching games online through, 5G networks. So if a person is watching a certain sports event from home, then if network slicing is also enabled, then we can assure that if if we do have the network slice for enhanced mobile broadband, we can provide the users with high gigabits of data rates and terabits up to terabits of data rates within 1 second. So that is the case. The users can stay at home and watch the game without any hassle. So network slicing concept can be used for such kind of data intensive tasks as well. Another area that could be using network slicing is this dynamic robots and applications related to robots and control systems. So when robots are working, they need a frequent access to the network. They have different data rate requirements based on the application. So the heavy, data rate requirements uh, uh, since it is required, the network slicing concept can be useful in that situation. So in such ways, network slicing has been currently, used in some special applications, such as this robotics, um, online gaming, or like real-time game events, and disaster recovery purposes, and so on. So that is how network slicing has been incorporated in the network infrastructures. So any questions up to now? Okay, so with the network slicing, the main concept is that network slicing refers to the deployment of multiple virtual networks on the same physical infrastructure to provide uh, customer-centric services. So it is basically the deployment of multiple virtual networks. So deployment of multiple virtual networks using the same physical infrastructure or on top of the same physical infrastructure to cater different customer needs. So the limitation of network slicing is that although it is a very effective concept, implementation wise, it's complex. Implementation of this network slicing is a concept task. I mean, complex task. I mean, the implementation is a complex task, right? So complexity of implementation is a problem because it has to be done using this, virtual network concept, and these virtual networks must be correctly, designed and deployed such a way that each of the slices are isolated and do not like impact the other slice. So, creating such kind of virtual networks logically is a kind of a daunting task. So that I mean, implementation wise, it's still a complex task. However, like as I said, like some companies are already implementing that, and little by little they will improve. So as of now, virtual networks uh, like implementation of multiple virtual networks simultaneously on the same infrastructure poses some challenges because isolation between the network slices has to be maintained, and also the resource sharing has to be controlled properly. uh, so on and so on. The resource sharing has to be done properly between each slice. So between each slice, the resources must be shared um, properly. So isolation has to be maintained between slices. Um, so likewise, we have to also consider some aspects such as security between slices, or security within slices, security of the data in slices. So that needs to be considered as another aspect. So such kind of things are there that that we need to we need to ensure when we are implementing network slicing concept. So like complex network slicing implementation still is a challenge even to the mobile operating systems. However, they are currently using that to create different slices, maybe one or two slices for different applications. So those are the limitations of network slicing. I think that we have discussed like quite some time regarding the network slicing concept. I think that with those content that we discussed, I think you will be able to go ahead with the network slicing concept and you know provide any answers, provide answers if somebody has any questions regarding that. So I will give you a small quiz related to the network slicing concept and also about the software defined technology. So please join. Okay, I believe everybody has joined. I will start. Is it okay? There's some more to join. I think now it's okay, right? Yes, so the correct answer is creating virtual networks on top of a common network infrastructure. Yes, the correct answer is customizing network services for diverse applications. Okay, so the correct answer is enhanced mobile broadband. Correct answer is network layer. Like this is working in the network layer, which is why we are using SDN and network function virtualization concepts in the network slicing. So other layers, such as application layer, works with data related to the data that you receive. So, where you use protocols such as HTTP, maybe MQTT, COAP, likewise. So like something related to network functioning is not there. Data link layer refers to the like the technologies that you use to transmit data packets in certain like using some technologies related to the uh, related to the uh, related to the transmission in terms of the frame length of the data packet and so on. So data link layer was not involved with the network slicing, and transport layer is uh, a layer which concerns about the transport layer protocols such as transmission uh, control protocol and the user datagram protocol, so TCP, UDP protocols, and also it is related to encryption functions. So those functions were not related to network slicing directly. So the correct most answer is the network layer. So the correct answer is provides flexible and programmable network infrastructure. In SDN technology, you are using softwares to control the network infrastructure, and you actually you use softwares to control control the network and also automate the network functions at each network component. So SDN technology is basically used for controlling the network traffic, and that will be done using its you know uh, programs, software programs that it has already been having installed in. So programmability and flexibility is something that SDN provides to the network infrastructure. So the network complexity increasing is not a correct answer to this question. So because you are actually um, I mean, SDN actually tries to reduce the network traffic in the network slicing concept. So network traffic controlling is done by SDN, so which actually increases the efficiency in the network slicing concept. However, yeah, if you're concerning about the implementation of network slices, it is true that it is complex to create a slice. But in here, what I'm referring to is the technology SDN and how it impacts the network slicing. So that is a different, question, a different way about the network slicing. It's a different thing. So if you have any doubts regarding that, you can ask. So the SDN does not increase complexity in the network slicing. SDN controls the network traffic in the network slices. The network slice generation of each slice can be complex. However, that is a different thing. That network slicing generation is something that you need to do initially, even before applying SDN architecture or SDN technology to this network slice. So the correct answer is by customizing service parameters based on application requirements. So the quality of service is something that defines the service that the network slice is providing to each customer. So when we are having network slicing, we can provide different quality of services requested by different services that were requested by the customer. So the customer needs different quality of service levels. Based on that, different network slices are created. So therefore, the network slices will customize the service parameters based on the application requirements. So other like facts, by reducing overall network capacity, it's actually wrong. I think the same answer is repeated twice. It's wrong because it doesn't reduce the network capacity. It means that network capacity is something good, actually. Network capacity means that how many devices that the network can serve at a certain time. So if the network capacity is high, that means it can serve multiple number of devices. If we are reducing the network capacity, it actually means that we are reducing the number of devices that we can serve at a certain time. So it is a disadvantage, actually. The correct answer is online gaming, where you need low latency communications to provide real-time gaming experience. So with that, I think the quiz ends. I will put these results in the LMS. With regard to the field visit, I have uploaded a Google form in the LMS to for you to fill. So if possible, try to complete it whenever you can. Before actually this week's Friday, if you are going to participate in this field visit. It's already, I think, already in the LMS. Hopefully, you can access it. So if you cannot access it, you can let me know. I think, don't know why it is never coming in. I think I shared the link in the other Google workspace also. Maybe you can access it. No. So I have shared the link of that Google form in this chat as well. So if you have, you can enter that. You can, I think, try to access that. So this is the form. So the deadline is 19th January of 2024, which means this week, Friday. So before 12 noon, please try to fill this. So based on that, I will arrange the visit. In there, we are hoping to visit the IoT, application centers at Oriel. So in there, they have some, smart home applications, smart agricultural IoT applications, and smart, you know, uh, industrial applications, which means that in industries, in the industrial, uh, I mean, in the industrial premises, uh, they also use IoT, and specifically, they are also using technologies such as digital twins, which is kind of the concept which is new actually, and it is used to create a twin of a certain process using software. So that kind of things you can see. So I think that would be also useful. So with the next uh, session, I will be discussing about the cloud computing technologies. Up to this point, do you have any questions? Any questions? So with regard to the IoT lectures, I hope to complete the section on these computing technologies, and then I will move on towards industrial IoT um, related session. So industrial IoT related session I will do next. After that, we will do a session on machine learning for IoT. And after that, I think that would be the end of all the lectures. After that, I think I can discuss with you the last year sample paper if required. Otherwise, I think I will, allow you to, watch the last year's tutorial that I have done. So I think you can, study from that. So cloud computing and computing technologies are what we are going to discuss in today's class. In the upcoming classes, we will be doing about industrial IoT. After that, we will be doing something about machine learning and how machine learning can be applied in IoT. So with regard to cloud computing, we will have a look at different types of computing first. So not only cloud computing, we do have other types of computing, and some main computing technologies are basically cloud computing, which is done at the cloud servers. So cloud servers are available in data centers, and the data centers have a collection of servers or computers which are highly, powerful computers located at a data center. So the cloud computing is done at a certain specific location where there's a large number of computers connected together that have many capabilities. So the cloud servers are able to store data, store massive amounts of data because it has a lot of storage space, and also it can manage the data from a uh, uh, from a certain centralized location. And also the cloud servers will be able to protect the data, secure the data, and do many functions such as network virtualization functions also on the data, such that it can control and manage the data efficiently in the data center. So anyway, like cloud computing uh, can be done in this specific location where the data center is located. And then we have other types of computing, which are fog computing and edge computing. So fog computing is a technology that is used between the edge and the cloud of the network. So what do we mean by this? Cloud and edge. What do we mean by this cloud? And the edge concepts. So the cloud, as I said, is a separate, data center or it's a center where we have a large number of devices which can do computationally difficult tasks, and they are actually located in one place in the world, in some certain locations in the world. And the network that connects these cloud servers with the local network has certain network components, and one or like several places in the intermediate locations can be considered as a fog server. So the fog server is a server that is located in an intermediate location between an edge and the cloud of the network. So the fog computing can be done in an intermediate location, and it is also another possible way of doing computing. Then edge computing is done at the edge of the network. So what do we mean by the edge of the network? So the edge is defined as the point where the local network ends. The point where the local network ends is known as the edge. The edge is something that is at the edge of the local network. At the edge, we have a certain edge server, which will do the tasks related to the data it receives from the local network. And sometimes it will do all the computation by itself and give back the feedback to the devices in the local network. So such kind of applications will actually have a greater impact when the application requires low latency, right? So one example is that when we have some kind of emergency in the area, we don't have time to upload the data to the cloud server. So in that case, if the edge server can do all the computations and give back the decision to the devices, then the devices will be able to react based on that. So what I mean by is that if there's an accident occurring in the area, if the message is sent to the edge server can notify all the vehicles in the nearby area regarding the accident and send those vehicles in a certain different route than the accident location. So for such kind of applications, we can use edge computing. So edge computing is a technology which is currently emerging, and therefore, if you can do some research into this area, this will be, I think, a good technology to work on. So as I said before, cloud computing is like a computing that you are doing on a cloud database or data center. So in there, actually, the cloud provider or the provider who's providing this services is having a large, large data center that houses multiple of computers that are supercomputers that have the capability of doing multiple computations at a certain time instance and do many functions related to data storage, data backup, data security, data analysis, and so on. So such kind of advantages lies with the cloud computing. So any questions up to that point? So I think in the concepts related to cloud computing, we discussed about other types of computing, such as fog computing, edge computing, and so on. So when we are discussing about these computing technologies, cloud computing is the most popular computing technology, I believe, and therefore remains like quite popular uh, because it is kind of known to many people who are using tech. So we have cloud computing engineers, cloud, architects, and so on. There are many, courses offered and positions offered in industry related to cloud. So, why do we need cloud computing, and what are the advantages of cloud computing? So actually, cloud computing refers to the data and applications running in the cloud servers rather than running them in your own local computer. So in cloud computing, basically, you'll be running and storing data in your own in a data center, and you will be uploading those data into the cloud servers. So in the cloud computing, you will be performing multiple functions, and you will be doing something like related to data processing, web application hosting, and so on. So basically, there are three approaches to the computing methods. So these computing methods are basically, categorized based on the location where we are doing the processing. So the three approaches that we are going to discuss is cloud, fog, and edge. So when we discuss about the differences of these computing methods, mainly these computing methods are categorized based on the location where the data processing is done. So based on the location where the data processing is done, these computing methods are categorized. So the cloud computing is done at the cloud data centers, where you have a specific centralized data center which is accessible to um, like to many customers, and it is available through the internet. So you can access the cloud using internet. So when we discuss about the fog computing, it is in an intermediate location between the cloud and the edge. So when we discuss about the edge computing is done at the edge of the network, right? So at the edge of the local network. So what we mean by the edge of the local network is that if there is a certain network which is connected to the uh, network infrastructure, then you will have a set of devices which are connected to the local network through a certain access point. So this is the local network, and the location where the network connects with the offsite network is known as the point where the edge is. So the point where this access point is connected to the another router or switch, which connects that to uh, the rest of the network that can be accessed, uh, that can be connected to the internet, is considered as the edge of the network. So in here we can say that the place where the edge server is located, that has that in where we can do the computation in the local network, we can call that as the location where the edge is. So in this diagram, if I'm going to show that, this access point in here will be basically a base station. So if you have a certain processing unit which is connected to the base station, we can consider that as the edge server. So the edge server will do the necessary computations related to the data received through this local network. The data has been received through the base station, and the data has been stored in the edge server. The edge server will be therefore kind of the server which is doing the computation, and the place where this edge server will be connected to the network, we can call as the edge of the network. So we can actually connect the edge server to the network. So the point where this local network ends, we call as the edge of the network. So we can call this point where the edge is connecting to another new network, we can call as the edge. So in here, we can call, in this point, we can call the edge is there. So this is the network which is connected to the edge, which is having connection to the internet and so on, and cloud servers and so on. So, so this kind of a network will have this edge computing scenario, and also the network which is in between the cloud server. We consider that this is the cloud server, which is connected to again another network component in the internet. You know, the cloud server will be connected to one of the network components in the internet, and therefore will have access to the internet. The intermediate network that transfers the data from the cloud server to the destination. I mean, where you need to do some computation, will have the fog computing location. So in an intermediate location, we will have a location where we can do fog computing, and that intermediate location should have a certain server which can have the ability, which will have the ability of doing the computation. So in this intermediate location, when we are doing computing, we'll be able to do the fog computing and the computing related to the fog server. So the fog computing will be done in an intermediate location between the edge server and the cloud server. It will be done in an intermediate location in the network that is transferring data between the considered IoT network and the cloud server. So the fog computing is used to do computation whenever there's some kind of a requirement to do the computation in an intermediate location rather than sending all the data to the cloud server. So what I mean by that is that in some cases where we have large number of devices connected to the IoT network at the local area, we might not be able to send all the data to the cloud server. The cloud server can be located in some specific place such as USA or India or somewhere that is distant to us. If we are having IoT network in Sri Lanka, sometimes uploading the data to a data center even in India could be, delay. It could be adding delay to the communication. So rather than sending to the Indian cloud server, we can do the computation in an intermediate server which is located near to this local network. And by doing that, we can do the computation in this intermediate location and get the work done and resend the feedback to the IoT network. So by doing so, we can, we can actually reduce the delay that is being spent to send the data to the cloud server. So such kind of applications are where the fog computing comes into play. So any questions up to now? So in today's class, we'll be mainly focusing on the cloud computing services. So the cloud computing services we will discuss, and in the next sessions, we hope to talk about the fog computing and edge computing in detail. So those kind of computings we'll be discussing in the next session. In today's session, we'll be discussing about the cloud computing and related technologies. So as of now, cloud computing has many, companies who are like using cloud computing, one thing, and there are companies who are providing cloud services. So anyway, like with regard to cloud computing, cloud computing can provide um, services such as data processing, web application hosting, running applications, storing data, etc. So cloud computing anyway refers to the uh, the computations that can be done in the cloud server, which are difficult to be done in the local computers. So cloud computing refers to the process of conducting computationally complex tasks, tasks in cloud servers instead of running them on your local computers. Instead of the local computers. Right. So because of that, like cloud computing offers us services uh, such that the local computers do not need to be used, and the local computers resources uh, can be actually sometimes saved, and we can use the resources in the cloud server. So there are many reasons why we need to use cloud computing, and some of those resources, reasons are like this. So why we need cloud computing? Why we need cloud computing, or what are the advantages of cloud computing? So, yeah, so as I said just a while in here, so the local computers will not be used for cloud computing. The local computers, some of the some of the features can be used. However, like cloud computing will enable most of the work to be done at the cloud servers. So when we are using cloud computing, we will be um, we will be able to reduce the risk of losing the data, and also you will be able to you will be able to reduce the usage of the local resources. So anyway, first reason can be the reduce the risks of the losing of data. So the reason being that if you upload it to the cloud, then even if something happens to your local computer, then the data will still be safe, right? So when you're uploading your assignments or your submissions into the Google Drive, you will be able to store the information in the Google Drive rather than in your local computer. So once that happens, even if your local computer crashes and it doesn't work anymore, you will still have your assignments and submissions in the Google Drive. So whenever you have such kind of problems with your local computer, you will anyway have a backup in the Google Drive. So in such cases, the cloud computing allow us to keep a backup of our data in the cloud, and we can reduce the risks of losing data. Another reason is that the cost is reduced. The cost of implementing a computing task is less once we use cloud computing. So it's actually cost efficient to use the cloud rather than using local hardware, software, and other resources. So it's cost efficient to use cloud resources instead of local resources, instead of local hardware, software resources, and other network, other resources. Another use is the scalability. So the word scalability refers to uh, the uh, the fact that the scalability of the network can be I mean addressed. So if you have less number of devices connected to the cloud servers, the cloud service will be provided to that less number of devices. And if you keep increasing the devices connected to the network, even that would be addressed by the cloud servers without any problem. So that is what we call as the scalability, which means you can increase the number of devices connected to the cloud server, but even then the performance of the cloud servers will not deteriorate. And also the customers can rent as many servers as they want, right? Uh, the customers can rent number of servers based on their requirement, and so sometimes their requirement will increase and then they will need more servers, and sometimes the requirement will decrease, and in that sometimes the earlier rented devices will have to be returned back, or we don't need that amount of devices. In such kind of cases, sometimes you can lower the amount of resources you want as well. So dynamically you can adjust the amount of resources that you need from the cloud server. So the cloud provides that flexibility to the customer. The customer can anytime define and update the amount of resources they are using. So the customer dynamically can dynamically adjust the requirement, adjust the I mean adjust the resources that it requires. Resources that it requires from the cloud. So based on that dynamic requirement, the cloud servers will be allocated. So it can be done in a flexible manner. Another thing is that the reliability of the cloud computing is high, which means that if you want to um, so the reliability of the cloud computing is high, which means that the reliability of the computations is high. So when we are considering applications where we have some critical data that we need to process, such kind of data can be reliably processed using cloud servers. Can be processed, analyzed, and make accurate predictions using cloud servers. So the critical data can be processed, stored, and analyzed using the cloud service, and we can give the decisions also quickly back to the customer using the cloud service. So the delay might vary, but at the cloud server, we can do the computation very quickly. Then data analysis tasks can be done very efficiently using the cloud servers. So that is one of the main important aspects or the important points to remember about the cloud servers. So the cloud servers have the computational ability to do computationally efficient or computationally costly tasks. So such tasks, computationally costly tasks, can be done using this cloud service. So such kind of tasks remain tasks related to machine learning, big data, uh, mining, and so on, right? So computationally costly tasks can be done using this cloud servers. So this includes machine learning tasks. Machine learning tasks, machine learning tasks include the training of the data, testing of the data, and make predictions of the new test data, and so on. So such kind of processes require us to have a lot of processing power at the computing location. So in most of the cases, you cannot do them in the local computers. So that is the reason that we use cloud tools such as, like Google Colab, Jupyter, and so on to do the data analysis part in machine learning tasks. So those kind of tools will be held in the Google, for example, Google Colab will be held in the Google Cloud, so on. So those kind of cloud servers can hold the machine learning tasks. And also the data storage is another advantage of data cloud computing. So that is one of the main advantages to the customer, where you have enough space to store your data. Sometimes you have to spend money to store the data, but there's a large volume of storage space available. So you can use the space for your tasks. And also, like, the security of the data can be maintained, and therefore it's another advantage of the cloud computing. Data security can be maintained at the cloud server using many techniques such as firewalling, and it can also do encryption and authentication processes can be applied to the communication. So with those kind of additions, security can be maintained at the cloud server level. Data security and privacy. So for ensuring security, we can include encryption methods, decryption methods. Then for privacy, we can include authentication methods. So if a certain unknown user tries to log into your account, they cannot log in without authenticating their identity. So because of those things, security and privacy is high at the cloud computers. So those are the main benefits of cloud computing. So if you know more advantages, you can let me know. And also, so these are not the only advantages of cloud computing. You can add more. Like if I am to tell like another advantage is about the remote monitoring. So the cloud computers enable any customer to remotely monitor the certain IoT network from a remote location, right? So with the cloud computing technology, the user can access the cloud servers using a certain application and remotely monitor the kind of the network which is in consideration. So remote monitoring can be enabled with the cloud computers. So the customer who's accessing the cloud server can obtain idea or knowledge about the updated information about the network in consideration. In here, I think we have this small like diagram. So if we are using this is the cloud server. A certain remote user can access this cloud server by accessing one of the network components in the network, and then one of the access points in the network, and then by accessing the network it can access the cloud server. So after that it can obtain data regarding its specific use application to which the user is authenticated, and after that the user can access the data. So the data will be frequently updated in the cloud server, and that data will be like useful for the user who's accessing this network from a remote location. So the remote locations, uh, the user can be in a remote location, and the user can access the cloud server. The cloud server will give updated data regarding the network in consideration. So up to that point, this is regarding cloud computing. So when we discuss about the other aspects of cloud computing uh, is providing three different services, mainly like software as a service, platform as a service, and infrastructure as a service. So the cloud services basically can be divided into three. So cloud services can be basically divided into three types. The cloud services which will be done as a infrastructure as a service, infrastructure as a service. Its acronym is IaaS, platform as a service. Which is PaaS, and software as a service. So this is SaaS. So these are the main service types that the cloud services can provide. So these services will differ based on the amount of resources that the cloud server will provide to the user. When we are considering about this infrastructure as a service, the cloud service provider will provide all the components, or many of the components to the customer. What I mean by is that the cloud server will give ownership of many resources to the customer. So basically, if you are considering this infrastructure as a service, the cloud server will provide the certain customer with the operating system, middleware, and other resources, data, application, all those resources will be provided. So the cloud server will provide access to application development, access to data storage, data analysis, data management, those things, and access to operating system, access to middleware. Middleware means the services. So middleware means the services or softwares that are used to interact with different APIs and provide services. So middleware is like a certain, like kind of like a intermediate interface that connects the cloud server with different services and provide a certain output to the customer. So the cloud server will provide access to application data, operating system, middleware to the customer. So these things will be available to the customer. The customer can adjust any of these components according to their own requirement. However, like the cloud server will also have some functions to do on their own side. Although they are giving the infrastructure as a service, the cloud server will also have some functions in this service model, where the cloud server will be responsible for the networking tasks, network function virtualization tasks. So networking tasks, then hardware management tasks, hardware management tasks for the cloud server management tasks will be done. And then storage will be done by the cloud server. Virtualization will be handled by the cloud server. So network virtualization will be handled by the cloud server. So the that network virtualization operation will be handled by specific controllers in the cloud server. Those controllers will control the network data based on the virtualization concepts and control the data traffic in the network. So the cloud will also provide these services apart from giving the access to these components, application component, data component, and operating system, middleware, and so on. So that is regarding the infrastructure as a service model. In there, actually, the customers are provided with a lot of services, such that the customer can customize these different aspects according to their own requirement and necessity. So I think I will discuss about the next sections about the platform as a service, software as a service in the upcoming session. I believe that I was not able to take your attendance, so I will give that attendance marking for you to. So kindly mark your attendance if possible. So there are many cloud service providers in the world which are popular. So one of the main cloud service providers are Amazon Web Services, Microsoft Azure, Google Cloud, Alibaba, IBM, and so on. So the main service provider is Amazon Web Services, and they are able to provide uh, services to customers such as Netflix and so on. So uh, such kind of uh, big companies rely on these cloud servers. The basically the cloud server will do almost all the tasks for them. So if we take the Netflix application, the storage of the video files, security of those kind of files will be taken care of by the cloud servers. So the high cost of maintaining will also taken care of by the cloud servers, and data backup will be done. So once those basic functions are handled by the cloud server, the Netflix company is able to focus on their own works. So that is the advantage that is gained by the customer due to cloud computing. So with related to the other service models, such as platform as a service, software as a service, I think we will discuss in the next session. So I believe I have covered some sections related to computing also in today's class. So if you have any questions, you can let me know. So in this week's Friday lecture also, you can come and meet me during the classes. I will be in the hall. I will not be delivering theory there. So if you have any questions to ask regarding the project, you can come. Also, you can be prepared to do the IoT project and come, so that if you face any problems, you can let me know. You need to come up with the hardware and software that is required to build your IoT project. So if you have marked your attendance, you can, if you have no questions, you're free to leave. Others, if you have any questions, you can let me know. So thank you so much for participating today. That's all for today.
Thank you very much, Miss.